Please go. There we go. Right. Hello, everyone. Welcome. I am very confused, both the title of this presentation and my current state. We've got 25 minutes to make you identity and access management specialists. First, who am I? Someone who can operate it correctly. Hello, my name is Tom. I'm currently a principal consultant at Control Plane. More on that in a bit. Was an ex-CISO of Ava Security, got bought by Motorola, been kind of faffing about in this field for about 12 years now, got a few CVEs to my name, I've got blogs coming up and you can catch me at DEF CON later this year, got a few certifications if you're interested, got an amazing website, that's just my opinion. Who is Control Plane? We are a cybersecurity consultancy company. We kind of specialise in cloud and Kubernetes-based pen tests and secure design. What else do we do? We do source code security, supply chain, a bunch of stuff. All kinds of different verticals for like DevSecOps, agile training, and threat modelling. If you're interested, come speak to us. We've got a booth at the back. We also are primary contributors to Flux, if any of you use it, we do like a short version of that, with lots of sort of good things. Right, identity and access management. I picked this meme very specifically because this is how I feel whenever I talk to someone about IAM. Don't worry, I'm more scared than you are. You can tell how long someone's worked in IAM by kind of the middle distance they stare out into whenever you mention a little twitch every time you mention parts of management. What is it? It's 3 A's. You've got authentication, authorization, and audit, which is who are you? Are you allowed to do that? And please make note of it. This is referred to as AuthN. This is referred to as AuthZ, which is very difficult for me because I'm British. So I spell it like this. The Americans spell it with a Z. I like to teach the standard, but also I like to be right. So it's a difficult place to be. We're going to be talking about AuthZ today. I'm using Z, the American, and not the Z, but you get the point. What is it? Basically, it's the process of determining what resources and actions you are allowed to perform. So you have a human, or a machine, or a smiley face. It goes into a policy decision point, which then takes a bunch of context, time of day of access, IP address, etc. You feed in a policy, which we'll touch into, and then this goes into a policy enforcement point, and then you say, yes, no, sorry, no, you're not allowed to do that, yes, you are allowed to do that, or step up authentication to FA, etc. Where do we use this? You use it all in your business. I assume you do. You don't just let anyone come in the doors unless you test them. You have like permissions on Google Workspace and internal application things, and you also have products. So a lot of people these days, you're building a software as a service platform or something like that. You need to implement some kind of IAM in your system. What's very weird is these things cross over a lot in modern businesses. You will end up in some situation where you want to protect some piece of data, and you'll end up writing your own product in your own business to provide some sort of defense. A very good example of this is in one of my old companies. We had a custom application running Kubernetes to control port forwarding to certain pods. And if you wanted to access our Postgres database directly, you went logged into this application and it went through a manual review process to get approval from people, all through OpenID, and then would open the port for you, which was a nice way of auditing this activity. I'm going to basically run through all the different kinds of IAM, and I'm going to talk about some cool ways to implement it in your business. So first off, attribute-based access control. What is this? This is the idea of putting tags or sticky notes onto things within your business. These can be kind of, well, project is this secret, is this restricted, and you can apply these things to like anything. What's cool about them is they can be static or dynamic. So any of you people running in cloud, when you set up a new EC2 instance, you can automatically just slap a label on that and say, this is controlled by the engineering team, or this might contain restricted information. And you can do the same with like Terraform or documents created in a folder. Lots of different ways of doing that. These can be environmental, of like what hours are people working. Is this a remote connection? These are commonly used for step-up authentication. If it's remote, get into 2FA. What kind of 2FA are they using? You can have metadata about the authentication themselves. This is commonly used in AuthZ, if you've ever had the pleasure of using Azure. Their conditional access is very good for these kind of things. You can lock down those logins very securely by how people are authenticating. And you can also have, based on the action they're performing, this is commonly used as a risk score. Are you transferring £10,000 on a Sunday over a remote connection? Probably not the best idea. I borrowed this slide from Amazon, which I think is a very good example of kind of showing different teams, people working in those teams manage resources. And this is the primary thing you get out of actually base access control. Very simple policy. Infrastructure team looks after infrastructure things. Some policies, infrastructure team looks after infrastructure things. But then you can also do very complex things like the finance team on a remote connection, when they provide it to a phone on a known device, can access restricted documents. Advantages and disadvantages. Scales incredibly well for the business. Cannot always be as fine-grained as you want it. The nicest thing about it is you link these with sources of truth. So you don't need to worry about keeping your policies up to date because the sticky labels are on your company directory or on your cloud environment. If it doesn't have a label, it doesn't get enforced. Scale really well. Policy-based access control is a terribly overused term. Horrifically. Basically, you've written some kind of policy some way in code or as code or is code that implements a policy, you're doing this. As code, I've got a Python example here of just an admin can access the admin page on a working. You can implement policy as code, and you can also implement in code, which is when you have like some kind of, like in this case I've got an Amazon policy document and you can see here the admin and they can do everything on S3. And I've got an example in a Rego policy which we're going to touch on slightly later. Easy to audit, easy to review, can be incredibly fine-grained, tends to get out of control incredibly quickly as your business grows. You bring in a new technology, you need a new policy, and you're kind of constantly iterating on this. Role-based access control. We've all used this before. It's old, reliable. We've got like an actor, a role, a set of permissions, baking cake. There it is. We've all seen this before. The example I'm used to this is on CCTV in my house. You have like a user, they have a view-only role. The role is there. They have a set of permissions. You enforce the access. Very easy to implement. Gets the job done in most cases. Is probably what you already have in your business and you're already using and might already be happy with it. Fantastic. The disadvantage of this is you end up in role explosion, especially if you're using something like Active Directory. You create a new role, you're constantly creating them, and then someone ends up with like 50 of them on the business or 100 of them in order to do the role, and then you run into weird situations where like AD only allows so many groups to be attached inside of Kerberos ticket and all your authentication rights in all your business. I only talk about that from experience. But yeah, there's some options. I want to very specifically take a side grade into semantics. Not everything is always this cut and dry. Attribute-based access control is theory at the end of the day, because in order to implement this, all these tags, you need a policy in order to take all of those tags and make a policy decision. And if those attributes are a collection of roles, you've accidentally implemented role access control. And I specifically called this out so that in your careers, when you're talking to people about access control, at any point in the conversation, you can turn to them and say, you are technically correct. Because you always are, because you're always falling on some of these systems, and you are always technically correct. But this is something important to hold in mind when you're designing these things. Who knows what that Pokemon is? What have I got? Jigglypuff. Jigglypuff, anyone else? Congratulations, it's Jigglypuff. But to actually answer the question here, so all the ones I've spoken about before are kind of the traditional access control systems. We're going to talk about a new access control system that Google implemented in 2000, or their paper was released in 2019, called Zanzibar, Google's consistent global authorization system. So Google Photos, Calendar, Cloud, Drive, Maps, and YouTube all use this system that Google created is a proprietary technology, but the paper of how it works and how it's hung together has been made open to the world. And it's a little bit different. I wanted to go through a few slides on this because it's new, it's interesting, it might work very well in your business. The idea is based on graph theory. We have a model, which is kind of how do the relations in this graph work, and we have a thing called tuples, which is the data that is stored in the database that is these relationships. A very good example of this is, funny enough, Google Drive. So you have these types of like a document, and a user, and a folder, and a bunch of other things, and then you define some relationships. For example, a user can be an owner on a document. Kind of get the idea? And then you can also have like meta relationships, where a viewer or an owner or a viewer of a parent folder can read a document. Good old graph theory stuff, and you end up with a very pretty graph explaining all of these relationships, which is very cool. How does this work in practice? I want to share my presentation with my brother. There he is. You click the send button, and a tuple is generated for that action, which says, my brother, George, is going to be an editor of this document. And then that tuple gets inserted into the database. This is globally consistent, deployed across everything, can handle a very large number of requests. And then my brother receives said document. Google Drive says, hey, can George can read this presentation. And the database then looks at that model to understand how all these relationships exist. It looks at all those collections of tuples and says, yes, George has a relationship, can read with this document, and the access is granted. That's how it works. It has a bunch of really nice properties. It can scale massively with your business. It's incredibly fast. Google internally gets this down to something like 10 milliseconds per check, which is really quick. And you can do reverse indices, which is really nice when you can take an item in the database like a document and ask the database who has access to this, and it can very easily explain that to you. The disadvantages of this, if you bring it into your business, it's going to be awful because you have to take all of that knowledge that you might have in a bunch of other places and then put it into this database. And you end up with lots of duplication of data where you grant someone access to something and that might be stored in a different application, then you have to replicate it into the database. But at the end of the day, it is very nice when well implemented. But that's it. Congratulations, you're now IAM specialist. You can take my award and go off into business and say you know everything about IAM. I now wanted to cover some implementations, some ways you can take this technology and use it in your businesses. None of these are sponsors. This is just what's out there currently. We have AuthZ, which was made by ex-Googlers, inspired by Google Zanzibar. They have SpiceDB, which is their implementation of Google Zanzibar, but made open source. They have this as a product. If you want to dabble with it, this is a nice way to get started. We have OpenFGA, which stands for Fine Grained Access Control, which is the CNCF project. This is the more open source version of it. Originally developed by AuthZ and Okta. These guys, in my opinion, have the best documentation for getting started with Zanzibar-like technologies. If you're just reading their docs, it's definitely valuable for your time. Again, open source. If you're doing policy-based access control, OPA, Open Policy Agent, is your bread and butter. It's the policies written in a language called Rego. You can read data from external sources, bring them into OPA to make a policy decision. You are probably already using this in your business somewhere. If you run anything Kubernetes related, Gatekeeper implements its policies through this. If you're creating a new business or a microservice, I'd highly recommend looking at combining Envoy with OPA. This works really, really well because your application development teams can develop an application. The security team can then put Envoy proxy in front with your policies and implement really nice fine-grained access controls. and gives you a nice way of meshing the two teams and being able to have scalable, consistent testing. A bunch of developer support. Who likes Amazon IAM? We got one middling response. Well, they open sourced it, which I was a bit surprised to say, and it's called Cedar. It is basically Amazon IAM as an open source project. You can write policies like you normally do and implement a bunch of access control. Amazon, unsurprisingly, will sell this to you as a product called Amazon Verified Permissions. But it's a really nice way if you're building an application and you want to implement a permission system and you're already in the Amazon ecosystem to do so. It's incredibly cheap. It works very, very well. A company called Permit.io actually took this all together and they created Cedar Agent, which is a HTTP implementation of the Cedar authorization language that you can then integrate into a bunch of your projects if you don't want to be tied to Amazon. They also created Opal, which is a layer that sits on top of this so that when you make changes to your policies, they can dynamically push out to all of your little agents whenever you make a policy change. And what's nice about this is it also works with OPA. So if you're in a situation where you have hundreds of microservices all using OPA as your authorization engine, you can put this together and manage the dynamic policy configuration changes. We have OSO, which I've been here. It's an interesting product, and I don't have enough time to explain to you, but they have a very nice data model for doing relationship-based access control like Zanzibar, but with better ways of ingesting the data without having to put everything in a Zanzibar-based database. It's very interesting. I would give it a look. They are coming out with an on-prem version soon. It's interesting. And last but not least, Cerberus, which is another authorization. It's fully open source. They support role-based access control and attributes access control. And they have a nice little cloud offering that can connect all of your authorization logs into a single point. Another good one if you're deploying in Kubernetes and have thousands of policy agents. It's also just kind of a cool little project. The main thing I really, really want to stress with anything access control related is keep a decision log. Really look at your business, understand it, and write it all down. Because in 1 year, 2 years, 30 seconds, you're going to have someone asking you, why did we go down this? Why did we make this decision? And the reason is because you're always balancing these things. How easy is it to use? How easy is it to maintain? Do you get the expressiveness out of the policy language for your business? How compatible it is for everything and how much you're paying for it, both in the upfront cost of money, but also how long does it take people to train this? If you ever try to explain to someone Rego in an hour, please come and talk to me. How? I need to learn that. But these things are important to consider. Perfect is the enemy of good. Remember, your authorization engine is going to be with you for the rest of your business until you then place it. It's really important that you understand it, you get it right, you write down, you understand why you made that decision. But that's it. Thank you very much. 18 minutes. That was a lot quicker than I thought. The slides are there. My website, add me on LinkedIn, and feel free to ask me any questions. And thank you.
Genuinely have time for questions.
I did it.
The auction's been pushed back a few minutes, so genuinely have questions. Sure enough.
So with Zanzibar, presumably one of the goals is that the graph database can be replicated in lots of places, so the thing that makes the decision doesn't have to be central.
Yes. So Google Zanzibar specifically is built on top of Google Spanner technology. So that's already their globally consistent database. And I believe the same about the OpenFDA and the other products allow for replication. But at the end of the day, it is still a central point for your authorization. Mm-hmm. There's still one thing making this.
Execution is distributed. Policy central.
They're both the same thing in Zanzibar. Whereas all the other ones I spoke about, the policies then loaded into them, they have distributed execution. Yep.
I work with a lot of smaller SaaS companies, and it feels sometimes that they've been railroaded into basically producing that RBAC strategy based on the tech stack that they chose probably 15, 20 years ago. Have you got any advice on how to move forward from that?
I feel like in a lot of those cases, you need to understand at a technical level how they are making those authorization decisions and what frameworks they are using. And then from a review of that, there's a lot of like OPA and all these other products have really nice SDKs that you can easily integrate into existing applications. And then trying to push them down that road into the migration. Maybe a new thing that you implement uses that policy decision point and you tie it into an existing language. Or the other route is forget about everything that they've implemented, put an access policy in front, like an Envoy with OPA, and do it all there, and then you can possibly move to something that's a little bit nicer. Anyone? Yeah?
Have you looked at CL much?
Cell, yes. I had the pleasure of writing that recently. I like Cell. I think it is quite difficult to write and more difficult for people to read. I think it's a very good, fast execution language for evaluating policies. I think it's a little bit difficult. It's not as approachable as I think it should be. They're both not great. But yeah. It also doesn't implement forms. And it technically does, but again, it's confusing. Any more?
Yeah. So, from a pen testing perspective, it's a massive faff testing like involved against all the different endpoints in a web app, say. Have you got any suggestions for tooling around that? Because sometimes it feels like the developers say they think they're doing one thing, but then when you're actually testing the actual app as it's deployed, it just doesn't like it.
The only thing I ever... So one of the reasons for using these systems is specifically around centralization of these policies and making these policy checks easier. For your particular situation, I always recommend white box testing, always, because you need to understand how the code are making those decisions, and then the first thing you do is just Google the endpoints that don't even use that check. And I think that's really the only approach. For testing black box is really difficult and not really worth the time.
All right. Well, yeah, thank you.